Hello mathematicians, welcome to our next topic, coordinate geometry. Now our first area of focus here, points and intervals, concentrates on simply dividing an interval up into various parts or getting the length of an interval. So for the first one, and this very first part should be, and I hesitate to say this, but it should be a repeat of material covered in Year 9. So, for an interval AB joining these 2 points, the length of the interval is given by this. It's called the distance formula. Sometimes it might have D instead of L. But the main thing to realise is that we don't need to memorise this formula. The distance formula is just the application of Pythagoras' theorem. So there's a GeoGebra here. We're not going to go to it because we can get by without it. So if we had these 2 points, this one and this one, if we want the distance between them, so the length of this interval, AB, then if we construct a right angle triangle, then we can see from that right angle triangle that the length of this side is simply the difference in the x values. So we're going from -4 across to 6, so that's a distance of 10. And the difference in the y values, we're going from 4 to -2, so that's a distance of 6. So we simply have a right angle triangle whose sides are 10 and 6. So of course the length of this side is the square root of 10 squared plus 6 squared, just by Pythagoras. So this formula up here in a way is redundant. And it's a little misleading, so I've written it with the y's first, but it doesn't have to be that way. It can be the x's. The main thing is to recognise we want the difference in the y values and the difference in the x values as the thing that we're squaring. So let's have a look at these examples. Now I'm only going to do one of these two. And while you can do this without a diagram, for me, if you draw up a diagram at every chance you get, it just helps your interpretation of the question. So we want the length of the interval from -2 to 7, so it just makes me think about which is the x and which is the y. So here's -2, 7, and b is 3, -5, so it's down here somewhere. And when I look at those pairs of points, then I'm getting the length of this line just here. If I wish to, I can then really easily see the triangle if I want to go without the formula. So the difference between the x values, I'm going from -2 across to 3, so that's a distance of 5. And the difference between the y values, it's 7 down to -5, so that's a distance of 12. Now, once I've got that there, you might remember 5, 12, 13 as a triad, or if not, you can use that this is the square root of 5 squared plus 12 squared. Now, to me, that's the advantage of having the triangle, of having the diagram. We can see at a glance whether it's a triangle that we're familiar with. And it can also stop me making silly mistakes, mixing up x's and y's and so on. The second question here, we've got that these points are the vertices of a quadrilateral, and we want to find the lengths of all 4 sides. So again, it helps me keep track of it. Even on the sort of drawings that I do, I can have a vague idea of the quadrilateral. So point A is 3, 1, so on a very rough scale, that's A. Point B is 10, 2, so a long way further out and not much higher up. So there's B at 10, 2. C is 5, 7, so up here somewhere. And D is -2, 6, so D is across here, -2, and up 6. So what does my quadrilateral look like? Well, vaguely like this, I guess. And then first step is find the lengths of all 4 sides. So if I do that, it's just my distance formula. Now, I could imagine my triangle in here for all of these if I wished, but I'm happy enough this time to just use the distance formula. So if I find the length of CD, then it's the difference in the x's or the y's, doesn't matter which ones I start with, as long as I get the difference. So it's a difference of 1 in the y's squared and a difference of 7 in the x's squared, so I get the square root of 50. For what that's worth, it's 5 root 2 from our knowledge of surds. Now, I'll have a look at AB, and even my crappy diagram led me to look at AB next. So my difference in the x's is 7. My difference in the y's from 1 to 2 is 1. So again, that's going to be 5 root 2. Then if I go to AD or DA, doesn't matter. So my difference in the x's is from -2 across to 3. So that's 5. And my difference in the y's is also 5. So it's the square root of 50, again, 5 root 2. And we're expecting, I hope, that CB will be similar sort of thing. So it helps us to avoid silly errors. So the difference in the x's is 5, so this is 5 squared. Difference in the y's is 5, this is 5 squared, so it's another 5 root 2. So what sort of quadrilateral is ABCD? Well, some of you might jump to the conclusion that all 4 sides are the same, so it's a square. But we can see, even from my diagram, it's not a square. So what's the shape with all 4 sides when the 4 sides are not at right angles to each other? It's a rhombus. Now this bit is not the critical bit for us at the moment, it's this bit, being able to use the distance formula. The next thing we look at is midpoint. So again, there's a formal definition for an interval AB joining these 2 points. The midpoint is given by this formula, which looks impressive, but what it's really saying is take the average of the x's and the average of the y's to get halfway between each of them. And that's all that it is. So again, I don't think you really need to memorize this formula. You just use the interpretation of it. So for our A and B just here, then we average the x's. So it's 6 plus minus 4, which is 2, divided by 2, which gives us 1. And minus 2 plus 4, which is plus 2, divided by 2, which is 1. And we get the midpoint just there. So that this distance is exactly equal to that distance. Or we've divided it in the ratio 1 to 1. Or here to here is twice as long as here to here. There are lots of different ways we can think about it. So read the question to think about what it's actually asking for. So once again, we want the midpoint of each interval. We could just use the formula, but because I am, as you will probably come to appreciate, obsessed by the diagrams, let's have a look at this one, and I would do a quick sketch. So -4, 7, -4, 7, somewhere up there, it's clearly not to scale, and 8, -11 out here somewhere, and I want halfway along that line, and this is just so I can see if my answer makes some sense. So the average of the x's, 8 plus minus 4 divided by 2 is 4 divided by 2, which is 2, that looks okay. 7 plus minus 11 is minus 4 divided by 2 is minus 2. Even on my diagram, that looks possible. Question 8. Find the midpoint of the interval joining these 2. So I'll spare you. So midpoint of the interval joining these 2 is 4 plus minus 2, which is 2 divided by 2, which is 1. Midpoint of the y values, 9 plus 3 is 12 divided by 2 is 6. So that's the midpoint of AC. The midpoint of the interval joining BD is going to be 0 plus 2 is 2, divided by 2 is 1. 8 plus 4 is 12, divided by 2 is 6. And then what I notice is that the midpoint of both of these lines is 1, 6. So that means, even though I don't know without drawing a SketchUp that these are the diagonals of the quadrilateral, but what I do know is that these two lines, AC and BD, intersect each other at 1, 6. So if we're told that we've got a quadrilateral and we're told that the diagonals intersect, then what sort of quadrilateral is that? Well, to be honest, I'm not too worried about this bit because that's geometry, which is another topic, but it should be a parallelogram.